So in this test we're going to do a second attempt of the temperature tower. Now this is the first version, or version 1.2 that I printed with the extended base, but one of the things I found with the previous tower is that the weight of the overhangs forced the middle tower to fall over. So it was an unsuccessful attempt in that respect. So what I'm doing now is I'm doing version 2 of this particular test, and what I'm going to do is I'm going to basically approach the project from a slightly different angle, and I'm going to remove some of the, or I have removed some of the complexities of that particular model. So essentially the original idea for this was to do a temperature test as the head moved between the two towers, the three towers, backwards and forwards, and then increase the temperature at the beginning and then reduce the temperature as it goes up throughout the model, and that way we can get an idea of whether the stringiness will reduce and how temperature affects the accuracy of the print whilst carrying out a number of different tests along the way. The overhangs were too much for it, so I've removed that. So what we essentially have is we have the base, which has an indented logo. We have three columns, one which is square or rectangular, one which is cylindrical, circular, and then we've got a star shape. Now the idea with a star shape is to check the accuracy of being able to reproduce effectively a relatively complex object as it goes up the tower, because you've got the central stem and then you've got the 5 points. So I want to see whether temperature has an effect on reproducing or reducing the accuracy of the print when it does the star shape. Then we have the cylindrical tower. This has a circle or another cylinder cut out from within the middle. It has these indentations. Now these indentations are there basically to allow me to identify the layer heights, so that as I'm going through the model I can work out where the layers are in order to hard code the temperature changes into the GCode file itself. Plus they also serve as a way of identifying whether the printer can reproduce an accurate dimple at that particular point in the tower. Also on the back of the tower you've got a cutout, so I want to see how it approaches that cutout. And then on the square tower what we have is a smooth side, because I want to see it smooth all the way up. We've got 3D, the words 3D or the letters 3D on the back. Then on the right, or on this side as we're looking at it now, on this face we've got these cutouts at a slant on the way up, and then we've actually got the temperature, so we know what temperature it was at this particular point when it's creating the model. I've left the base, well I've kind of come up with a base that should be thick enough and also wide enough to support the towers, and importantly within this particular test we have no overhangs, so there shouldn't be anything to actually unbalance the model as it prints. So that is our completed second attempt, and this should work. Certainly based on what I've learnt from the previous test, this should work. So it should be successful. I don't know how successful it will be in terms of reducing the stringiness or the accuracy of the final print in terms of all the different layers and the temperature changes, but it certainly shouldn't fall over, as I believe. So now what we need to do is we need to export this as an STL file, load the STL file into Cura, slice it to make our GCode file, and then edit the GCode file so we can work out where all the layers are and then set the temperature changes at each layer. So that's the next step. So we select the model, or we select all items of the model, and then we do File, Export, and then STL. Now one of the important things that we do here is we click on Selection Only, and that will ensure that it will only export what we need it to export, and none of the shapes that are being used as the cutout. So there we save the file, and now we can go into Cura. So here we are in Cura, and here is our model, and if we zoom in and then if I move this around we can actually see there's the representation of our model. We've got all our cutouts, all our shapes, everything exactly as we need it to be. and then we click on, I'm going to keep on the settings exactly as they were for the previous test, so I'm not going to change anything here. We'll start off at the same 200 degrees printing temperature at the base, and then override the G-code file so we can do 230 down to 180 as we go up. We've got the build plate 60 degrees, layer height at 0.12 millimeter, all the rest of the settings exactly as they were. So we click on slice. So it's going to take 2.5 hours, it's going to be 4 grams in weight, and it's 1.32 meters of filament. So click Save to Disk, and then we can open the G-code file in Repetier and also Notepad. Now, as I mentioned in my previous video, I'm actually a little bit more familiar with Repetier than I am with Cura, because this is the program that comes on the memory stick by Artillery, and it's the slicer I was using first of all, and one of the things I'm aware that it has, which Cura may have but I'm not aware of that yet, is this G-code editor. And what this allows you to do is basically visualize the print as if it were printing. So one of the reasons I've put these dimples in place is to identify where we are in the tower. So if I go into show layer range, and then I start at layer 0 and then build up, and then as we go up the tower, we can see that we've got these values, or sorry, these layer heights. So what I want to do is use this dimple as the first indicator of where the layer I need to identify the first temperature change. So at this point, I want to basically increase the temperature to 230, and then as I go, and then that means we can print here, knowing that it's 230 degrees. And then as we come up, we've got the next layer here, and I'll change it to 220, so we know that when it's printing the next layer, we've got 220 degrees. And then 210 here, and then keep going, 210, etc., all the way up the tower. Now, what I've actually done is I've already made a note of these particular numbers, and if we go to my little notes here, so layer 24 is 230, layer 84 is 220. So what we can actually do then is modify the G-code file with those temperatures. So the temperature, we set the temperature with M104, and that's the temperature, and then we wait for the temperature to be 200 before proceeding. So if we search for layer 24, so layer 24, and here we can see is our layer, and then what we can do is we can basically put the overrides in to set the temperature at that particular time. And we can do that by copying that, then going to layer 24, and then pasting that in. So we've got 230, 230, and then I go back and I look for layer 84, so layer 84, and this is going to be 220. And then the next layer, which is 148, is going to be 210. So layer 148, 210, 210, and our next layer is going to be 200 at 208, so 208, and that's 200, same as we started with. And then our next one is going to be 270, so it's layer 270, it's going to be 190 degrees, so layer 270, 190, 190, and then finally layer 330 is going to be 180. So search for layer 330, and we're going to set this to 180. Now with that done, and we'll save that file. So essentially we'll copy this onto the memory stick, transfer it over to the Artillery Sidewinder X1, and then when it prints, basically as it gets to each layer height, it will set the temperature wait for the temperature to be in effect, and then continue printing. So that way, as it's going up the tower, we know it's 230, we know it's 220, we know it's 210, and then we'll be able to ascertain as to what difference the temperature has on the quality of the model and also the stringiness of the model as it's going between the towers. So let's see how this goes. And here we are in time-lapse mode, and the whole process took 2.5 hours. So again, I don't want you to wait that long for it to print, so I've sped it up by about 25-30 times so that we've got all of that time condensed into a very short video. And as you can see, the layers are building and building, and I kept coming back about every 10-20 minutes or so just to make sure everything was okay and it didn't fall over or anything or get stuck in any way. And I'm pleased to report that it continued building all the way up, and the outcome was actually pretty good. It didn't fall over, it was very stable, and as you can see in the pictures, what we've ended up with is actually kind of what we'd anticipated, but the only problem is the stringiness, and I still am not sure what's causing the stringiness in between the model, especially as by reducing the print temperatures, I would have thought that that would actually reduce the stringiness based on what I've read already. So there must be something else to it in terms of the settings. So retraction was enabled, the settings, the temperature settings are changing. So the fact that it's stringy all the way up the model suggests to me that there must be something else at fault. So I'm going to do some more investigation myself and then see if we can work out in the next test exactly what the problem is. Thank you for watching.